In this session, we are going to learn about sets in Python. So far, we have seen lists, which are ordered collections that allow duplicates, tuples, which are ordered but cannot be changed, dictionaries, which map keys to values. Sets are different. A set is an unordered collection of unique items. So there are two key properties. Unordered, the items don't have positions, so we cannot use indexing. And the second property is they're unique. Duplicates are automatically removed. If you try to add the same thing twice, Python will only keep one copy. Sets are especially useful when you want to remove duplicates, check membership quickly, or perform mathematical operations like union, intersection, and difference. So let's just start by creating a set. A set of fruits like apple, cherry, and another apple. Let me print this. When I run this, the output is plum, apple, and cherry. So notice what happened here. I wrote apple twice, but Python only kept one. That's the uniqueness property of sets. If I want to make an empty set, I cannot just write curly braces because curly braces creates an empty dictionary. Instead, I use the set function. For an empty set, we use set function. Curly braces is used when we want to create an empty dictionary. So let me run this. So the first one is a set, the second one is curly braces, which is a dictionary. So empty dictionary, curly braces, empty set, use the set function. Now let's see how we can add and remove items. Sets are mutable, which means we can add and remove items. For adding items, we use the add method. Fruits, let me run this, and the output will be orange, plum, apple, and cherry. Notice the order may be different on your screen because sets don't guarantee order. Now let's see how we can remove items. We use remove function for that. So here is the updated list or updated set. But if I try to remove something that isn't there, for example, let me try remove something that is not there. Fruits, remove, for example, mango, I get an error. So to avoid errors, we can use discard function like fruits discard mango, then print fruits. Notice no error and the set stays the same. Now let's talk about random removal. The pop method removes and returns a random element because sets don't have order. Remove the fruits print on my screen. The output is remove orange and remaining apple and cherry. But for you it might remove a different element because the order is not fixed. So now let's talk about membership tests. One of the most powerful uses of sets is fast membership testing. Let me create a set. And let me run this. So the output will be the first one, that's true. Apple is in the set. Apple is in the set. But for the second one, orange is not in the set. So the output is false. This works much faster than checking in a list when you have large datasets. For example, checking if a number is in a set of million numbers is much faster than checking in a list of million numbers. Now let's talk about set operations and mathematical operations we can perform with sets. The first operation is union. combine all items. The union operation combines items from two sets, removing duplicates. For example, let me create a set called A, and the items in this set is 1, 2, 3. Another one with the items of 3, 4, and 5. Print A union B. The output for both will be 1, 2, 3, 4, 5. Both notations give the same result. We took everything from both sets, but the duplicate 3 appears only once. The other operation is intersection. The intersection operation gives us only the items that appears in both sets. Print A and B, or print A intersection B. So the output for both is 3. The only common item between A and B is 3. The next operation is difference. The difference operation keeps items in one set but removes any that also appear in the other. For example, print A minus B and print B minus A. Let me run this. So the output for the first one is 1 and 2. A minus B keeps 1 and 2, and B minus 4 keeps 4 and 5. The next operation is symmetric difference. The symmetric difference operation gives items that are in either set but not in both. And how we do that? Print asymmetric difference B. So we remove the common 3 and keep everything else. Now let's talk about subset, superset, and disjoint. So using this, we compare sets with relationships. Let me create a set called X, and the items in this set are 1 and 2. Another set Y, which contains 1, 2, 3, 4. Print X is subset Y print y is superset x, and print x is disjoint five, 6. Let me run this and see what happens. So the output for all three are true. Each subset is true because 1 and 2 is contained inside 1, 2, 3, 4. Each superset is also true because y contains all items of x. Each disjoint is true because this set x shares nothing with 5 and 6. Now let's look at some real-world examples where sets are very handy. Example 1 is about removing duplicates. Let me create a list of numbers. So this is a list 1, 2, 2, 3, 4, 4, and 5, and get the unique numbers from this list. We set it to set first, set numbers, convert it to set, then print the unique numbers. So converting the list to a set instantly removes duplicates. Another example, let's do, for example, shared hobbies. Let's say that I have a set of the hobbies for Emma, and those are reading, music, and one more, for example, hiking. And another set of hobbies for Bob, and those are, let's say, music, hiking, and another, let's do this one, a different hobby, traveling. So we can print Emma and Bob, and the output will be music and hiking. So Emma and Bob both enjoy music and hiking. Example 3, let's do it on comparing, for example, restaurant menus. Or restaurant orders, let's do. Order 1 is a set of, let's do pizza, pasta, and salad. Let's do next one with burger. Now print common items. So what are the common items? Order 1 and order 2. We can also print all items, and that includes everything print only in order 1 and that is order 1 minus order 2. So let me run this. We are forgetting a comma here and here and here. Let me run this again. So the common items in both orders is pizza. It appears in both orders. All items, those items that appear in either order 1 or order 2, those are all items. And the items that only appear in order 1, so we have pasta and salad, so pizza is removed. So we can see what both people ordered, what's on the full menu, and what's unique to one order. In summary, a set is an unordered collection of unique items. Use curly braces or set to create sets. You can add with add function, remove with remove function, or discard and pop random elements with pop function. Set operations include union, so everything combined, intersection, only common items, difference, only in one set, symmetric difference, not shared, and we also talked about subset, superset, and disjoint. Sets are very useful for removing duplicates, comparing groups, and checking membership efficiently.